Jai Hind all of you. I am Dr. Rahul Bansal from Ajay Kumar Garg Engineering College, Ghaziabad. So this one is the next video lecture for the electronic devices KEC 301. So let us start. So in this video lecture, we will be discussing about the photodiode. So photodiode as the name suggests, the working of the photodiode depends on the light, right? And it is basically the PN junction diode. So simple representation for photodiode is, so this one is a simple representation for photodiode. It is basically the PN junction diode. So this side is P side and this side is N side, right? And here through this way we show that it is like light is introducing to this. Now if we see in this format, we can also represent this through this way also. So this is like PN junction diode and light is introduced at the junction. So this is also a representation for the photodiode, right? So this photodiode generally works in the reverse bias condition, right? So if you see carefully, normal PN junction diode, right? So if it is like reverse bias, so there will be a depletion layer formation. So this one is the depletion layer. So this side is like P side, this one is this N side. It consists of, this P side consists of holes and N consists of like electrons, right? And if you reverse bias this, right, if you reverse bias this such that this negative terminal of the battery is connected to P side and positive terminal of the battery is connected to the N side, then this is said to be in the reverse bias condition. So if you connect this like this, then this depletion width will increase, right? This depletion width consists of the immobile ions, okay, and electron and holes are bonded with the covalent bond, right? So that the electron and the hole don't contribute to the conductivity, right? So this is the normal photodiode. So if you see carefully, the current which is flowing is called as the minority charge carrier current. So this is like the current which is flowing. So this is actually the minority charge carrier current through this, if it is reverse bias, right? Now I'm not taking the direction into the consideration. Only the thing is the current which is flowing is minority charge carrier current. Now if you actually, the basic problem with this is, if we use this as a switch, the problem with this circuit is this current will be like less, right? And we cannot like detect this. This is in the like nanoampere or microampere. Now this will reduce the switch, the speed of the switch. Okay, so to increase the switch speed, what we have to do is we can introduce the light so that the charge carriers will be introduced. Okay, and for this, if we introduce the light, we have to code this using the photosensitive material. Okay, so photosensitive material, and you can just write here. What we require is photosensitive material. So what are the photosensitive materials? So ZNS, CDS, etc. These are called as the photosensitive material. Whenever the light is introduced at the junction, it will activate, okay, and light will be causing the an effect which is called as the photoconductive effect. So about the photoconductive effect, we will see this in the detail, right? So if you see this p-n junction diode, this is p side, so this one is n side. N side consists of electrons and p side consists of holes, right? And this side consists of the immobile ions, right? Now if we introduce the light, this is coated with the photosensitive material, and if we introduce the light through the lens, so lens is generally used to converge lights, right? So what it will do is, the electron hole pair which is already present at the depletion layer, right, with the covalent bond, this light energy will cause this covalent bond to break, right? And this covalent bond will break and electron hole pair will be generated, or you can say these charge carrier will be freed. Now these charge carrier will contribute towards the conductivity. So if you see this, this is reverse bias condition. This battery negative terminal is connected to the p side and this positive terminal is connected to the n side. Now you can see. So this current is like previously, which was flowing in the absence of light. It is like I naught. I naught is the minority charge carrier current, right? So I naught is actually temperature dependent parameter. So if you see this carefully, I naught is temperature dependent parameter. So if we change the temperature, then this I naught will change. So how does it relate to the temperature? So I naught at any temperature T2 is equal to I naught at any temperature T1 multiply by 2 raised to power T2 minus T1 divided by 10. So this is the mathematical relation that relates the minority charge carrier current. Suppose that at any temperature T1, say it is 10 degree Kelvin, the minority charge carrier current is 1 microampere. Now if we increase the temperature from the 10 degree Kelvin towards the 20 degree Kelvin, right? So the difference between the temperature is 10 degree Kelvin, right? So I naught at 20 degree Kelvin, it will be equal to I naught at T1, it is given as like 1 microampere. I naught at T2, that is at a 20 degree Kelvin, it will be I naught into I naught at a temperature T1 multiplied by 2 raised to T2 minus T1 divided by 10. To T2 minus T1 divided by 10 will be equal to 1, right? Because difference is 10 degree Kelvin. And this I naught will be multiplied by 2. So 2I1. So what postulate we can draw from this? We can say that for every 10 degree rise in temperature, minority charge carrier current will be doubled itself, right? So this is the postulate that we can draw. This is the conclusion we can say. Now this I naught, which is present in the absence of light, right? Now this I naught is called as the dark current, because this is the current which is flowing in the circuit whenever the light intensity is equal to 0. Now suppose that this light is introduced to the junction, then due to the breaking of covalent bond at the junction and generation of charge carriers, some more current will be flow. So it will be represented as I photon. This current is due to the photon energy. So I am just giving this name as I photon. Right. So I photon is dependent on the light energy that we are giving. Now this total current will be equal to, you can write here, total current will be equal to I naught plus I photon. Right. So through this way we can increase the speed of the switch. Right. Now if we see carefully, this I photon is dependent on this light current. More light energy is introduced, more will be the breaking of covalent bond, and more will be the value of this I photon current, right. So now next is the photoconductive effect. Due to the introduction of this light, covalent bond will be breaking. This will cause the increase in the current. This phenomena is called as the photoconductive effect. That is, conductivity has been introduced or increased due to the effect of light. So this is called as the photoconductive effect. Right. Now applications of this. Now it has the applications in like switches, right. Due to the increase in the conductivity due to the introduction of light, this can be used in the as a switch. Second application is in the optocouplers, right. So it is also used in the optocouplers many times, right. Next application is it is also used in the remote control sensors, right. So these are the different application of this, right. So now the same effect can be seen in the solar cell also. If we see the solar cell is basically the PN junction diode, right, which is operating in the reverse bias condition, right. So this side is like P side, this side is N side. Whenever this light is introduced to this, right, this is coated with the glass such that light energy will be trapped. Now if it is light energy is introduced to this, so what we do is we just left this as it is, and later we can apply the load so that this light energy can be used. Basically solar cell, what does it do? It converts the solar energy into the light energy. It will first store the charges, then it converts the this light energy to the electrical energy, right. So whenever this light is introduced to this, right, so the covalent bond electron hole pair, covalent bonded electron hole pair will be like generated, or you can say covalent bond will be broken due to the effect of this light, such that they will move like this one. Holes will be moving through this side and electron will be moving to this side, so due to this light energy. And here we have holes and electrons. If you see carefully, at this side holes will be collected, and here we have electron will be collected, right. Now this will create a potential difference, right. And if we connect a bulb through this circuit, then this bulb will glow, right? This bulb will glow. So this is the basic phenomena of using solar cell. This solar cell is also called as a photovoltaic cell, right? So this is how we can use the solar cell, and this is the basic principle of like using the solar cell. Now this is all for this video. Thank you all of you. Thank you.